The groundwork for the future of mobility is being laid. Alternative technologies are being developed and new concepts are being conceived that are both sustainable and resource-conserving. This begins with the motor cars themselves and, ideally, continues through all parts of the production process, right up to the internal material flow. Lead-acid batteries have been regarded as state-of-the-art technology for intralogistic trucks. However, these batteries also have their disadvantages. Charging and replacing lead-acid batteries takes a long time. Service life is limited if they are not correctly maintained. They lose power at extreme temperatures, require a large amount of space. Furthermore, the use of acid poses a risk to health. The fuel cell represents an alternative drive technology for intralogistic trucks. BMW, Linde Material Handling, and the Institute for Materials Handling, Material Flow and Logistics at the Technical University of Munich have partnered up to work on the H2IntraDrive research project, which aims to further develop this technology to a point where it's ready for series production. A fleet of 6 tow trucks and 5 forklift trucks with hydrogen-powered drives are being tested under normal operating conditions at the production site of the BMW i vehicles in Leipzig. Employing a fleet of intralogistics trucks powered by fuel cell technology will contribute significantly to the reduction of CO2 emissions and, of course, more efficient intralogistics. This is because the significantly reduced load time of the trucks considerably increases their level of availability. The latest generation of fuel cell systems is built using the same dimensions as a standard battery box. These systems essentially consist of a ballast weight serving as the component carrier, the hydrogen tank, cooling system, the fuel cell stack, and a lithium-ion rechargeable battery. The engineers at Linde Material Handling made numerous modifications to the chassis and constructed a new side door equipped with a service lid in order to integrate the fuel cell system. In addition, an additional ballast weight was added to compensate for the difference in weight between the lead-acid battery and the fuel cell system, as well as to maintain stability against tipping. A display provides the driver with information about the status of the fuel cell system. When driving or during normal operation, the fuel cell provides base load power, while the lithium-ion battery covers any performance peaks. Energy generated by the braking process is fed back to the battery, which increases the operating time of the truck. One of the biggest challenges of integrating these systems into the existing trucks is meeting and complying with our Linde safety standards to ensure safe operation for the customer at all times and to guarantee a very high degree of availability and quality. Prior to conducting the test operation at the BMW plant in Leipzig, the fuel cell trucks had passed all of the tests that are required for series production trucks from Linde Material Handling equipped with conventional drives. There were also certain requirements that had to be met at BMW before the field test could be performed. As part of the project, we first stipulated at BMW that each and every one of the parts to be fitted in the body shop had to be provided by industrial trucks powered by fuel cells. We also provided the infrastructure for refueling the trucks. As a result, we created the first indoor filling station for hydrogen-powered industrial trucks in Germany. The scientific work is focused on compiling and quantifying characteristic values, which allows for the reliability, efficiency and environmental sustainability of the trucks to be evaluated and for conclusions about the advantages and disadvantages of these new technologies to be made. The advantages of fuel cell systems are primarily reflected by the increased level of availability and productivity of the trucks. Batteries no longer have to be replaced. Instead, refueling is fast, there's less need for maintenance, and the trucks boast a constant level of performance even at extreme temperatures. All of this while being environmentally friendly and largely CO2 neutral thanks to the use of green hydrogen.